All right, number 15. C equal to 5/9 times parentheses F minus 32. The equation above shows how temperature F measured in degree Fahrenheit relates to a temperature C measured in degree Celsius. Based on the equation, which of the following must be true? Okay, so I have three statements here. Okay, so we can go through each statement and then see if it works. Okay, first let's look at this formula a little bit. Okay, C represents the Celsius, temperature in Celsius, and then F is Fahrenheit. So pretty much, if we know a temperature in Fahrenheit, we subtract 32 times the fraction 5/9. That will give us the temperature in Celsius. Okay, so this is the formula we use to convert from Celsius to Fahrenheit. Okay, that's or Fahrenheit to Celsius, and we can use this formula. All right, let's look at statement 1. Okay, statement 1 says a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Right? Is that a true statement? Well, so there are more than one way to think about this. Right? What we could do is we could use like a test number. Okay, so let's just say if we have Fahrenheit is like 32 degree, for example. Okay, here I picked 32 because that would be easier to solve. Okay, so if you plug in, let's say if you have Fahrenheit 32, to solve for the Celsius temperature, we can plug in 32 in for F into the formula. That would be 5/9 times 32 minus 32. But 32 minus 32, that's 0, right? 0 times anything is 0. Okay, so when the temperature is 32 degree Fahrenheit, the temperature in Celsius is actually 0 degrees. All right, and they say if we increase it by 1 degree, the Celsius should increase by 5/9. Yeah, so if we try that, so the Fahrenheit, if it's now 33 degrees, so we're going to increase it by 1. See, the Celsius will be 5/9 times 33 minus 32. 33 minus 32, that's 1, right? So 1 times 5/9 is 5/9. Okay, so Fahrenheit increased by 1 degree. And see how much the Celsius temperature increased. It went from 0 to 5/9. So it did increase by 5/9. Okay, so statement 1 is actually correct. Okay, statement 1 is correct. So what happens, the 5/9, that's the slope. Okay, so this is multiplied in front of us. So this is like the slope. So the slope tells us as the x value increased by 1, how much does the y value change? So for our equation here, the x value is like the Fahrenheit temperature. All right, so the slope tells us as the Fahrenheit increased by 1, the Celsius temperature had to increase by 5/9 because that's what the slope is. Okay, so statement 1 is a correct statement. So we're gonna look at the answer choices. Okay, so this is interesting. So for Roman numeral question like this, you always want to eliminate wrong answers as we go. Okay, so if we're confident with statement 1 being correct, we can eliminate B and C. Okay, and we can see that we only have answer A or D left, and A says 1 only and D says 1 and 2 only. So all we have to do is check statement 2, right, to differentiate between A or D. Okay, so we know statement 3 should be correct. Okay, so especially this will be very helpful if we're running short on time, right? We know we actually don't have to check statement 3. Okay, so look at statement 2. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degree Fahrenheit. Okay, so they're saying if we're increasing the Celsius temperature by 1, the Fahrenheit should increase by 1.8. Okay, so we can also check this by plugging in a test number. But it might be easier if we rearrange the formula a little bit first. Okay, let me just go ahead and do that. See, what we can do is, so now we're looking at the Fahrenheit temperature in terms of Celsius. So we can try to get F by itself. Okay, we can try to get F by itself. This might be helpful, especially this is no calculator session. So if we change the Celsius temperature on this side, might be more difficult to solve for the Fahrenheit. Okay, so we try to get F by itself. What we can do is first we can multiply by the reciprocal of 5/9. Okay, to cancel out a fraction and get multiplied by the reciprocal. So that would be 9/5, right? Okay, so we multiply by a 9/5 on both sides. The 5/9 and the 9/5, they cancel. Okay, so we have 9/5 equal to, on the right side, just F minus 32. All right, and then to get F by itself, we can do plus 32 on both sides. All right, that cancels out, so we get F by itself. So let me just put F on this side, and then that's equal to what? All that, right? So 9/5 plus 32, like that. Okay, so this is the equation when we rearrange it and try to get F by itself. This is what F equal to. And now we can plug in some test numbers. So when we have 1 degree increase in Celsius, do we have 1.8 degree increase in Fahrenheit? Well, what if, let's just say, what if C equal to 0? Okay, let's just say if C equal to 0. Okay, let's solve for F. Okay, when C equal to 0, let's solve for F. F will be 9/5 times 0. I picked 0 because it's easier to solve. But 32, right? That's 9/5 times 0, that's 0. Plus 32 is still 32. Right? When Celsius is 0, we know Fahrenheit temperature is 32. And when Celsius is 1, let's increase it by 1, the Fahrenheit temperature will be 9/5 times 1 plus 32, which is 9/5 plus 32. Okay, and 9/5 is this. We might want to do long division. 9 divided by 5. If you convert to a decimal, is actually, if I go to 9 one time and we subtract, we get 4 the remainder, and then we had to carry over another 0, right? Okay, so and then 5 go into 48 times. So I actually get 1.8, and the remainder is 0. Okay, and that's where the 1.8 came from. Right, so I get 1.8 plus 32. 1.8 plus 32, that's 33.8. So we compare the temperature, it went from 32 to 33.8. Yeah, it does increase by 1.8. Okay, and the 1.8 is pretty much the 9/5. That's the slope of this equation. Okay, so that means when Celsius increase by 1, the Fahrenheit should increase by whatever the slope is, right? That's 9/5, which is equal to 1.8. Okay, so that tells us statement 2 is also correct. Okay, statement 2 is also correct, so it had to be D. All right, now statement 3 is wrong because what? Yeah, statement 3 is doesn't work because as temperature increase by 5/9 degree Fahrenheit, right, is equal to temperature increase of 1 degree Celsius. So we said it earlier. So statement 1 is correct. Statement 3, they got it flipped, right? So it's actually, if we have 1 degree Celsius increase, like what we had here, right? So we have here, then we see that the Fahrenheit temperature actually increased by 9/5, right? Not 5/9. Okay, so that's why statement 3 is incorrect. Okay, so for our answer here, number 15 had to be D for this one.